Hello, um, welcome to the third video on differentiation. We're looking at implicit differentiation. So you can recognize a question that needs to be approached using implicit differentiation when the equation that you're differentiating is not written as y equals some function of x. It's like the example written here, there are x's and y's on both sides of the equal sign. This has to be approached using a method called implicit differentiation. So the main thing I want to try to get you to get out of the habit of is it's quite easy when you differentiate a function to begin by writing dy by dx equals, and that's just because it makes sense, doesn't it? Whenever you've been asked to differentiate something, you begin by writing dy by dx equals, and then you differentiate. Now, you need to get out of that habit for these questions, because if you write dy by dx equals as your first step, it's all going to go wrong because you've introduced a new dy by dx, which you haven't actually obtained from doing the differentiation. So instead of doing that, okay, I deleted my y there. Instead of doing that, what I want you to think of is sort of, rather than thinking, okay, dy by dx equals something, I want you to sort of start at the left-hand side of the equation and then just move through the equation, differentiating the things as you reach them. So we'll differentiate the 2x squared first, then we'll differentiate the minus 4y, and then we'll differentiate the cos y. Okay, so that's the idea. You just start at the left and move through the whole equation, differentiating as you go. So we are going to differentiate each of these with respect to x. Okay, so first of all, this 2x squared is just a normal function of x, so we differentiate that normally. So that becomes 4x. Okay, so now we continue moving across the equation and we find the next term has a y in it. So now we need to just know, for implicit differentiation, when you're differentiating a function of y with respect to x, a bit like with the chain rule, you first of all just pretend that you're differentiating it with respect to y. So you just treat it as, how do I differentiate 4x? Well, that 4x becomes 4. Well, 4y becomes 4 as well. The difference is, with all of these questions, once you've differentiated normally, you've then got to slap on a dy by dx. So we've got to multiply by dy by dx. So that is true for any function of y. You first differentiate sort of as you would intuitively expect to differentiate it, but then when you've done, stick a dy by dx next to it. Okay, so for example, it doesn't just work for polynomial curves, it works for the trig functions as well. So cos y, when you differentiate cos y, it becomes minus sine y. And then we've got to multiply that by dy by dx. It might look slightly ambiguous there, so it might be worth either putting the dy by dx in front of the sine y, or just adding some brackets around the y, just to make it clear that the dy by dx is not in the argument of sine. We are just multiplying afterwards. And similarly, if you differentiate e to the power of something to do with y, when you write down the dy by dx, it doesn't go into the power of e, you just multiply it. Okay? So that is what we get once we've differentiated both sides of that equation. Then usually what you want is dy by dx. So we could rearrange that and make dy by dx the subject, and then we could do all the normal things, finding tangents, normals, and stationary points. I'm not going to do that here. We've got more examples coming where we do find dy by dx. I just want to look at one more example. Okay. So I've got a relatively simple example here. Now there's an X and a Y in this. So that tells you we need to do this implicitly. It's not written as Y equals a function of X. What we need to do then is, starting at the left-hand side, move through the equation and just differentiate everything as you come to it. Now, the thing here is we've actually got to use the product rule here because we've got two functions multiplied together. So if we call that one U and that one V, using the product rule, we need to do U dash V plus U V dash. Okay. Now, just because there's a implicit differentiation going on doesn't make it any difference, really. We still just use the product rule. We just need to remember that at any point, if we differentiate a function with y in it, we've got to slap on a dy by dx. So u dash v, so u is x squared, so u dash is 2x, and v is y squared. Now, we didn't differentiate the y squared, so we don't write dy by dx there. And then we add uv dash, so u is x squared, v dash is 2y dy by dx. Okay, it is a bit of a mess at the moment. I will need to rewrite that. We can't have that 2 there. And we must remember to continue differentiating. We've got to continue moving through this equation. We need to differentiate both sides of the equation. So 15 is differentiated normally, just like 15 always is. It just becomes 0. I am going to rewrite this because I don't like that 2 in the middle there. So we put plus 2x squared y dy by dx. Okay, and again, usually questions will want you to find dy by dx. So we would rearrange that to make dy by dx the subject. So that's it. That's the overview of implicit differentiation. You just differentiate functions of y sort of as if the functions of x, but then you've got to multiply by dy by dx. We're going to look at, I think, 3 past exam questions now. Okay, so here's a typical past exam question, 7 marks. It wants the equation of the normal at the point 0, 1, giving your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. So first of all, when we're reading an exam question, we want to figure out, okay, where is the information that's going to help me choose what to do next? Well, the fact is, the question's asking you to find a normal. Now, a normal is a straight line. So if we're being asked to find the equation of a straight line, that means we use the formula y minus y1 equals m bracket x minus x1. So that gives us some focus for this question. Once we find x1, y1, and m, we have found the equation of the tangent. Now, this question has been quite nice because it's already given us x1 and y1. So the only thing we need to find is m. So in order to find m, we need to find dy by dx. So let's, I'm just going to copy the equation down. And if you want to familiarize yourself with these kinds of questions, we're not used to seeing curves defined like this. Usually curves are defined as y equals a function of x. I would encourage you, if you've got a graphic calculator, type that formula in. The other option is there's an app you can download on your phone called Desmos, DESMOS. It's free, and you can type that in, and it'll give you a feel for what these curves look like. Usually when an equation has an x squared and a y squared in it, we usually get some sort of closed curve. You've seen that already with circles, haven't you? Circles have x squareds and y squareds in them. Now, if it can't be written as a bracket squared and another bracket squared equals a radius squared, the curve is probably more like an ellipse. Or it can be some other strange shapes as well, but they're quite complex. They're not functions, obviously, because if they're a closed curve, they're sort of many to many mappings, which wouldn't class as a function. Okay, so starting at the beginning and just working our way through, we just differentiate each term as we come to it. So 3x squared, we just differentiate that becomes 6x. 2y squared, just differentiate normally, so we get 4y, but then we've got to multiply by dy by dx. 2x becomes 2, 3y becomes 3, dy by dx. The 5 becomes nothing, and the nothing stays as nothing. So now we've got a formula with dy by dx is in there. So now it's time to make dy by dx the subject. So you need to do a factorization here because there's two terms that have dy by dx in them. So I'm just going to get I'm going to add both of those dy by dx terms to the right hand side. So we'll be left with 6x plus 2 equals 4y dy by dx plus 3 dy by dx. I chose to put them on the right just because it removed those negative symbols, so it looks a bit cleaner. So then we get 6x plus 2 equals, and now we factorize to get dy by dx. And now we can divide by 4y plus 3. I'm going to put dy by dx back on the left-hand side because it sort of looks more natural to say dy by dx equals. But it's going to be 6x plus 2 divided by 4y plus 3. And just have a quick check. Can we simplify that? It doesn't look like we can. There's no common factors on the top or the bottom, so that looks like our final answer. And notice we're used to functions where when you find dy by dx, the function that you end up with is only in terms of x. Now with implicit differentiation, the function you obtain will have a y in it as well. So the point that we are dealing with is the point 0, 1. Okay, so we need both the x and the y coordinates there. So at the point 0, 1, dy by dx is, just sub them in, it's going to be 6 times 0 plus 2 over 4 times 1 plus 3, which is 2 over 7. Now, if we go back to the question is not asking for the tangent to the curve, it's asking for the normal. So the difference between the normal and the tangent is that they are perpendicular. So the m that we want is going to be minus 7 over 2. We do the negative reciprocal of the gradient at that point, and it gives us a perpendicular gradient. So the normal then, we can go back to our equation, which was y minus y1, which is 1, equals m times x minus x1, which is 0. Okay, so to tidy this up, I'm going to multiply both sides by 2. We get 2y minus 2 equals minus 7x. And if we look again at the original question, it wants us to have all the terms on the left-hand side of the equation with 0 on the right. So if the question had just said find the equation of the normal, we would be fine with it in this form that we've got. But the question has instructed us to give it in a certain form, so we just need to rearrange it. And that's the equation of the normal. So as you can see, everything that you do with the dy by dx is the same as with other functions. The only difference is that finding dy by dx involves implicit differentiation, and you're probably going to need the y value as well as the x value. Okay, let's try another one. For this one, we're going to find the stationary points. So let's begin. X squared. And please, you have a go at this. Pause the video and have a go at this. Okay, so if you've had a go at this, hopefully you noticed that that second term required the product rule. So if you didn't notice that the second term involved the product rule, maybe pause again and have another go. Okay, so hopefully you've had a go and tried to use the product rule. So in order to find dy by dx, we just do the same thing as we were doing before. We start at the left and go through the equation, differentiating as we go. So the 2x squared becomes 2x. And here we've got a little product rule going on. So we're going to have to do u dash v plus uv dash. You're not expected to write that, by the way, in an answer. I'm just writing it there in red to remind you what the formula is. So the u will be 2x. So I might just put some brackets just to make sure I keep it separate. So obviously that 2, we could have the 2. We could either take the 2 out and use the product rule on x and y, or we could treat v as being 2y. So just make it clear in our heads. I've called 2x u. So u dash will be 2. So u dash v is just 2y. And again, remember, we didn't differentiate y there, so we do not put a dy by dx in. Plus u v dash, so u is 2x. V dash is, so if we've got y and we differentiate y, we get 1 dy by dx. So that's just dy by dx. And then we subtract 6y dy by dx. And the plus 16 becomes 0, and the 0 becomes 0. So this is a very similar example to the one we did previously. We've got our 2 dy by dx's. So we're going to make dy by dx the subject in the same way as before. I'm going to leave the dy by dx on the left-hand side this time. And move the x's and y's to the other side. So we've got minus 2x minus 2y. We can now factorize that left-hand side. Dy by dx bracket 2x minus 6y equals minus 2x minus 2y. And then divide to get dy by dx equals minus 2x minus 2y all over 2x minus 6y. Okay, I'm going to simplify that a little. We've got a common factor of 2 on the top and the bottom. And actually, there's a lot of minus signs. I didn't manage to avoid that. So I'm going to divide the top and bottom by minus 2. So we will get x plus y over 3y minus x. Okay, so that's my expression for dy by dx. Now, the question is asking us to find where dy by dx equals 0. So, start with that equation, dy by dx equals 0. That means x plus y over 3y minus x. equals 0. And now we've got a fraction equaling 0, which is quite nice because it just, if you've got a fraction equaling 0, that means the numerator must be 0. And here's the next unusual thing that happens with implicit differentiation questions. When we made dy by dx equal to 0, we haven't got an answer. We've got an equation as our answer. Now, what that means is, if we were, I encourage you to sketch the actual curves, okay? So let's say our curve looks something like this. I don't know. What we found is that those stationary points, we don't know the we haven't found the coordinates of them, but what we have found is that they lie on the line y equals x as well as on the curve. Okay, so if the point that we're interested in lies on the line y equals minus x and on the curve, defined by that long equation at the top there, we now need to solve the equations simultaneously. Okay. So let's get the, I'm just going to bring the equation down to where we're working on this. Okay. So one of the equations that we're going to solve simultaneously is the equation of the curve. And the other one is y equals minus x. Okay, so we've got simultaneous equations now. So in order to solve this, we need to substitute y equals minus x into the equation above. So x squared we'll leave as it is, 2xy, so y is minus x, minus 3y squared, which is minus x squared, plus 16 equals 0. That gives us x squared minus 2x squared minus 3x squared plus 16 equals 0. Which gives us, we've got x squared minus 2x squared minus 3x squared, so we've got 4x squared equals 16. Did I do that right? So yeah, we've got 16 minus 4x squared equals 0. Divide both sides by 4, we get x squared equals 4. So this means x equals plus or minus 2. Okay. So there are 2 points where the line crosses the curve, and that's common because, as I've said, these curves are often closed loops. So when you have a straight line, it often crosses it twice. We're nearly done though. So now we can substitute each of these values back into, well, we'll use this equation. It wouldn't make sense to substitute it into the other one. Both of these points are on the line y equals minus x. So when x is 2, y equals minus x, so y will be minus 2. And when x is minus 2, y will be 2. So those are the 2 points which are stationary on the original curve. So that's something to keep in mind. Don't be fooled when you try and find a stationary point and you end up with a function rather than a value. That's fine. You've just, by making dy by dx equals 0, you find a line that is also on the stationary point, so you've got to solve simultaneous equations. Okay, so we get 6x plus 8y dy by dx minus 2. And now we use the product rule. So u dash v will be 6y. And then u v dash will be 6x dy by dx. The minus 5 vanishes and the 0 is still 0. So now if I make dy by dx the subject, I can collect the dy by dx terms together and factorize. We get 8y plus 6x. And then on the other side, we get 2 minus 6x minus 6y. So dy by dx equals 2 minus 6x minus 6y all over 8y plus 6x. We can divide top and bottom by 2. So that gives us 1 minus 3x minus 3y all over 4y plus 3x. Now we want the gradient at the point 1, 2. Sorry, 1 minus 2. So at 1 minus 2, dy by dx equals 1 minus 3x, which is 3, minus 3y, which is plus 6, all over 4y, which is minus 8, plus 3x, which is plus 3. So that tells us that the gradient will be 1 minus 3 plus 6, which is 4. And minus 8 plus 3 is minus 5. So the gradient we're interested in is minus 4/5. The question is just asking for the equation of the tangent at 1 minus 2. So we use y minus y1 equals m times x minus x1. So we get y plus 2 equals minus 4/5 x minus 1. Multiply both sides by 5, we get 5y plus 10 equals minus 4 x minus 1. Expand that right-hand side, we get 5y plus 10 equals minus 4x plus 4. And again, with this question, it wanted everything on the left-hand side. So we get 4x plus 5y plus 6 equals 0. Okay. And finally, I just want to show you another example where the functions are not polynomial. So this is quite a long question in that it's got lots of parts to it. So let's work our way through this. So for part A, so we're going to just move through that equation, differentiating as we hit each term. So cos 2x becomes minus 2 sine 2x. Cos 3y becomes minus 3 sine 3y. But because we differentiated a function with y in it, we need to put on a dy by dx. Okay, and I'm going to put brackets around 3y to make it clear that dy by dx is not part of the argument of the sine function there. When we differentiate 1, we get 0. So now we want to make dy by dx the subject. So we get minus 3 sine 3y dy by dx equals 2 sine 2x. So dy by dx equals minus 2 sine 2x over 3 sine 3y. That's it. Okay. And now for the rest of this question, we are being asked to use these answers. I'm just going to put my answers to part A over there so that we can keep the question on the screen as we have got part B. So for B, the point P lies on C where x equals pi over 6. Find the value of y at P. So if x equals pi over 6, we're just asked for the value of y. So this is not asking us to use the expression we got for dy by dx. We're going to have to use the original equation. So we get cos 2x, so that'll be pi over 3, plus cos 3y equals 1. Now, cos pi over 3, we should know this. You can obviously tap it into your calculator to double check. Pi over 3 is 60 degrees. Cos of 60 is a half. So this becomes a half plus cos 3y equals 1. So cos 3y equals a half. So now the question is transformed into a trig equation type question. So this means 3y equals pi over 3 or 2 pi minus pi over 3. And now we need to think how many answers we are going to get. Well, the question tells us we're only going to get one answer. It says find the value of y at P. So we've got the restriction here on y. Y is between 0 and pi over 6. So that means 3y will be between 3 pi over 6, which is a half pi, and 0. Okay, so 2 pi minus pi over 3 is 5 pi over 3. Now that is too big, isn't it? The biggest value we can get for 3y is pi over 2. So 5 pi over 3 is too large. So we can reject that as one of our answers. And we are just left with 3y equals pi over 3. So that means y equals pi over 9. Now for part C, find the equation to the tangent at P, giving your answer in the form, there we go. It is, we want our constant term there in terms of pi. So for part C then, x1 is the x coordinate of P, which was given to us, it's pi over 6. y1 will be the term we worked out in part B. So we've got x1 and y1, we just need to find m. So at the point pi over 6, pi over 9, dy by dx equals minus 2 sine of 2x, so that's pi over 3, over 3 sine 3 pi, which is pi over 3. And we can save ourselves any embarrassment of not knowing what sine of pi over 3 is off the top of our heads, because those two terms are the same, they cancel out, so we're just left with minus 2/3. So we can now find the equation of the tangent. It's y minus y1 equals m times x minus x1 I'll begin by multiplying through by 3. So we get 3y minus pi over 3 equals, and I'm going to multiply out the right-hand side as well. So we get minus 2x plus 2 times pi over 6, which is pi over 3. Move everything to the left-hand side there. We get 2x plus 3y minus pi over 3 minus pi over 3 is, oops, I've written an equals, minus pi over 3 minus pi over 3 is minus 2 pi over 3. And that equals 0. At this point, we need to go, just to check the phrasing of the question. It said it wants the answer ax plus by plus c pi equals 0, which we've got. But it also says where a, b, and c are integers. So at the moment, our c term is not an integer, so we just need to multiply everything by 3. And there we go. Okay, thank you for watching, and good luck.